Okay guys, welcome back. Today we're going to use the discriminant and modeling data. So we're going to solve a few questions. We're going to solve it, guys. Remember, if you have any questions, thank you for the students who are emailing me their questions, telling me what they need, and everything's going fine. If you need anything, call the school. Now, let's go to the first question. Of course, the name of today's subject is the discriminant and modeling data. Okay, this is the main. We learned it. All we need to do is now practice it. So we have this table of values. Of course, you can see it. Now the question is, which kind of function best models the data in the table, graph the data, and write an equation to model the data. So if it's linear, quadratic, or exponential. Now, as you can see, each time, what do? Can I put it up a little bit more? Okay. Each time, from the -2 to the -3, from -3 to -4, etc. Each time we're adding 1. Okay, each time we're not dividing, we're not multiplying, we're adding 1. Which means because each time we're adding 1, -2 plus 1 is -3. I'm sorry, not we're adding 1, we're subtracting 1. Sorry about that. We're subtracting 1. -3 minus 1, -4, -4. So we're adding -1. Okay, we're adding -1. So because we're adding the same number, it means that it's linear. So it means that it's linear. Each time we're subtracting 1. And that is it. So it's of course linear. If we divide it or multiply, then it's going to be exponential sometimes. So in this case, as we know that it's linear, so it's either the first one or the second one, as you can see. Either we're subtracting 2, it's the x minus 2, or we're subtracting, or negative x minus 2. So we can just plug it in. So x is 0. Plug in 0 minus 2 is -2. If you plug in 0 here, it's also -2. So we go try another one, 1. So we plug in 1. 1 minus 2 is -1. But how much is the answer supposed to be? -3. So we plug in again, -1 minus 2 is -3. So the answer would be the second one. And that's how we do it. So the answer would be, so we need to choose the second one. The same thing, so in this case, look, from 10 to 2.5. Okay, from 2.5 to 0. Now you can see that the odds that it's exponential, right? But you need to see what's the growth, or in this case, not the growth, the decay factor, right? So let's do it. That is do. You can just plug in the numbers and find the answer. Okay, you can just plug in the numbers and find the answer. But the fact that it's 0, 0, so you just check, for example, you plug in -2 and you see which one gives you 10, okay? So if you plug in -2 here, you just get the calculator. Oh, where's the calculator? I lost, here it is. So it's not gonna be 10, okay? Remember, -2, it's gonna be 10. Here, if you plug it in, it's gonna be -10, which means no. That's, of course, it's not linear, right? And if you plug in, it's going to be -2. It's going to be 10. And so the last one is actually the answer. So it turns out that it's a quadratic equation, a quadratic one. So each time we multiply. So if you plug in the -2 squared 4 times 2.5 is 10. If you plug in for the -1, now the -1, we plug it in, -1 squared is 1, 1 times 2.5 is 2.5. 0, 0, if you plug in 0, it's going to be 0. If you plug in 1, it's going to be 2.5. If you plug in 2, it's going to be 10. Of course, how can you know that it's quadratic? It's because -2 and 2 have the same y. -1 and 1 has the same y, and that's how you know it's quadratic. So the answer is the last one. Okay? Find the number of real number solutions for the equation of. Now that's the one. And that's how we're going to use the discriminant. Now first one is the discriminant. Discriminant is this one. It's from the quadratic formula. D equals the square root of b squared minus 4ac. Okay, that's the discriminant. So without the square root here. Without the square root. Don't put the square root. What is it? Don't put the square root. Okay? So that's the discriminant, okay? Now, you need to use the discriminant to know how many solutions you have. Now, if the discriminant is bigger than 0, okay, it means that you have two solutions. If it's equals to 0, sorry, it means that you have one solution. If it's less than 0, it means you have no solution, 0 solutions. So all you need to do is plug in the B, plug in the A, plug in the C, and you'll find the answer. So the discriminant equals B is negative 10, so it's going to be negative 10 squared. Minus 4 times A is 1, times C is 25. So from here, the discriminant equals 0. So the answer, because the discriminant is 0, it means that we have one solution. That is it. Just remember, if it's bigger than 0, two solutions. Equals to 0, one solution. Less than 0, no solution. And that's the answer. The same thing here, guys. Now, the solution is the x-intercept. Okay, the solution is the x-intercept. Now look here. You see the graph? So, as you can see the graph intercepts with the x-axis where only once. It's here. Only once. So it means that we have one solution. It means that we have one solution, which means the discriminant has to equal to 0. So, which one would be the answer? The first one. And this one is the same thing, guys. We have negative 6, negative 9, negative 12. Each time, from negative 6 to negative 10, you can think that we multiply times 1.5. But from negative 9 to negative 12, it's not negative 1.5. So you need to check which one. You plug in the numbers. I'll let you do this one by yourself. So as a advice, try and find the ratio between negative 9 and negative 6. Then try to negative 12, negative 9, and etc. So you can find it. I'm not going to solve this one. I'm going to let it for you to solve. Or you can just plug in the values of x and the values of y. The same thing here. I'll let you solve it. Now, this one. Graph the set of points which models the most appropriate for the set. So when you have these points, we need to know if they're exponential, linear, or quadratic. Now, all you need to do is graph it, right? So, I hope the graph would be a little bit, accurate. We have negative 6, negative 1. So let's take the x. So we have negative 1. So 1, let's take this one, negative 1. We have, come on. This is negative 1. Sorry, guys. Now, we have x negative 1. We have 2. We have 3, 4, 5, 6. The same thing, we have 6 here, negative 6. And y we have from 7. So let's say this one is 7. And negative 1, negative 2, negative 3, negative 4, negative 5. So let's start with the first one, negative 6, negative 1. So this is negative 1, and this is negative, and the x is negative 6, and negative 1. So it's going to be here. That's the first one, okay? Negative 3, 2. Negative 3 and 2, so it's going to be negative 3, and 2, 1, 2. Let's say it's going to be here. Negative 1 and 4, so negative 1 and 4. Negative 1 and 4. So 3, 4. Let's say it's going to be here. 2 and 7, so 2 and 7 is going to be here. So as you can see, what do you think? It crosses it, you see? It crosses it. Okay? So as you can see from the graph, first you need to graph it. It's going to be linear because it's a straight line. That's it. That's the answer. Okay, for 7. 8. Find the number of real number solutions. That's another one for the discriminant. I'll zoom it. So again, guys, we need to find how many real solutions we have. So let's begin. We need D equals B squared minus 4AC. So as you can, the discriminant equals B is negative 13. So, sorry. 13, so it's going to be 169 minus 4 times A times C. So discriminant equals 169 minus 4 times 42 is 168. And D equals to 1. Not 1. Oh, yes. So the 1 is bigger than 0. So it means we have that 2 solutions. So the answer is 2. This one, guys, for example, if you look at the graph, this is the x-axis. The graph doesn't intersect the x-axis at all. It means that we don't have a solution, which means the discriminant is negative. It's less than 0. As you remember, if we said if the discriminant is less than 0, it means that we don't have a solution. Last one. This one is the same. As you can see, we have 1 x-intercept, means that the discriminant equals to 0, and this will be the answer. Okay, that is it, guys, for today. Have a wonderful day. Be safe, and